All right, you guys, so we're going to start Unit 6 over systems of equations, and we're going to learn a few different ways to be able to solve systems of equations. Today, we're going to keep it basic, and we're actually going to work on just graphing. This is familiar. We've done graphing of just one line at a time in slope-intercept form. Now we're going to throw in 2 lines. So that's what the system becomes, okay? System works together, and these lines do the same, okay? So a couple of things. You're actually solving the system for an ordered pair that makes it work for both of them at the same time. So the solution to a system of equations is the point where the 2 lines intersect each other, all right? You're going to write your answer as an ordered pair, like x comma y, just like a point. Where those 2 lines actually meet is what our answer is going to be. So if you look at this first example, they've graphed this line going down, they've graphed this line going across, and they intersect right here at this point. So that is the answer to that system of equations. The answer is an ordered pair. So it's x and then y. So if I go over on my x, I'm at 3. And then I go down to the point, and that's -2. So my answer to that system would be 3, -2. X and then y. Okay? Now, a couple of special things happen. If you guys remember, back when we used to solve equations all the time, you had 3 types of answers. One was just saying, oh, well, my answer is x equals 6. Right? Like we solved an equation and you plugged it in, that's what you got. Or if it didn't have an answer, like if it ended up saying 6 equals 4, well, that wasn't true. So our answer had no solution, or our equation had no solution. So that was an option. But if it said 6 equals 6, that means it worked all the time. So our equation had infinite solutions. And that was our third type of answer. Well, the same thing is going to happen when you do systems of equations. You're either going to have an exact answer, like this guy over here, where it has a point. It's not going to have an answer at all, or it's going to have infinitely many answers. So up here is a picture of 2 parallel lines. Parallel lines, like we learned in the last unit, are 2 lines that never intersect. Right? So if they never intersect, we can't ever write down an ordered pair for their answer because they don't have one. In this case, parallel lines give us no solution. Okay? Because they're never going to intersect, which means we're never going to have that ordered pair that we need. All right? Now, on the flip side, what would it look like if a line intersected at every single point with another line? So if I draw a line here and I want another line to intersect it at every single point on that line, in order to do that, I have to draw another line right on top of this line. Well, if that's the case, those 2 are the exact same line. So the only way to get infinite solutions is when it's the exact same line twice. Okay? So you're either going to have one answer where they intersect, no solution if they don't intersect at all, or if they intersect all the time and they're the same line, then we have infinite solutions. Okay? So just as a little reminder for you, slope-intercept form is y equals mx plus b, right? We've talked about this a million times now. Y equals mx plus b. M is our slope. It's a fraction. Remember, rise over run. We're going to go up if it's positive, down if it's negative, and always to the right. And then our y-intercept is our b, okay, on the y-axis. So graph that y-intercept first. From that point, graph the slope as rise over run. And then we have our line, and we'll see where they intersect. Okay, so here's our first one. Y equals 2x. Now, you're noticing that this one is our slope, but it doesn't have a b out here. So if it doesn't have one, hopefully you remember, that means it's 0. So I start at the origin with 0. My slope is 2 over 1, which means up 2, right 1, up 2, up 2, up 2. I'm just going to put in several. Now, if I need some down here in this section, I'm going to go the opposite direction. So down to left 1, down to left 1, and that will continue my line all the way across. Okay, so you want to be really nice and neat with these points because it's easier to see where they cross. If you need a ruler or anything in class, make sure you ask, okay? Now, my other one, x equals 4. Well, hopefully you're seeing it starts with an X, so it's special. This is a Vux line. Vux means vertical, up and down. It starts on the x-axis. So I go over to the x-axis at 4. My line will go straight up and down on 4. I kind of got off there a little bit. Let's try that again. Straight up and down at 4. Okay? And so my points intersect, or my lines intersect right at that point. Again, x, y is going to be our answer. So to get x, y, I have to go over 4, so that's my first point, and then up to 8. So 4, 8 would be my ordered pair for my answer. Okay? Where they intersect is our final answer. All right, let's do another one. We have 1/2 x plus 2. So I'm going to start at 2. 1/2 means I go up 1, right 2. Up 1, right 2, and I'm going to keep going here. And if I want some more on this side, I'm going to do down 1, left 2 to get a few more points. Put that line in there. Okay, and then let's do the bottom one. We've got 3x minus 3, so I'm going to start at -3. And then this would be 3 over 1. So up 3, 1, 2, 3, over 1. 1, 2, 3, over 1. 1, 2, 3, over 1. You notice they already intersected right on top of each other. There's my point. So I need an ordered pair. So I'm going to go over 1, 2, up 1, 2, 3. So 2, 3 is my ordered pair. Now, if you had to tell me why these two numbers work without showing me a graph, I want you to be able to know why. So if you think about it for a second, you can prove it to me because this is x and this is y. So I can plug these numbers in for x and y in the equations and they will work. Let's try it. This guy gives me 3 equals 1/2 times 2 plus 2. Well, half of 2 is 1 plus 2 equals 3. So that one worked. The bottom one, 3 equals 3 times 2 minus 3. 6 minus 3 equals 3. So that one works. So when you plug them in, they both work in both equations. And what's cool is it's the only set of numbers that will actually work. So if you try any other set, it won't work because they only intersect in one spot. Okay? All right. Let's go to the next one. Now, if you notice here, this actually has a different kind of equation on it. And so we can't graph this unless it's in slope-intercept form, right? So we wanted to say y equals mx plus b before we start. So let's do the first one. We'll get that one out of the way, and then we'll talk about the second one, okay? Y equals x minus 7. So I'm going to start down here at -7. Y equals x. So that's a 1 over 1. So I'm going to go up 1, right 1, and put in some points here. And then I'm going to go ahead and draw my line. Okay. Now, to be able to take this second one and put it in slope-intercept form, we have 2 steps. So I need the x on the right-hand side and the y all by itself. So that's what we're going to do. We're going to move the x to the right-hand side. So my first step is move x to the right. Okay? And I'm going to do that by either adding or subtracting. If it's a positive, I'll subtract it. If it's a negative, I'm going to add it. So I'm going to show you that step right here. X plus 4y equals negative 8. I'm going to subtract it because it's in positive. These are gone. I have 4y equals. Now, I'm going to write x first because it comes first in mx plus b. So negative x minus 8. Now, the second thing we have to get rid of is this 4 right here. And because it's being multiplied, our step is to divide by the y value. And the thing is, you have to divide all terms. So if I divide by 4 here, I have to divide by 4 here and 4 here. Those are gone. I'm left with y equals. This little part is now 1. So negative 1/4 x. And then negative 8 over 4 is negative 2. Now I'm ready to graph. Start at negative 2. Slope is down 1, right 4. So down 1, right 1, 2, 3, 4. Down 1, 1, 2, 3, 4. And there they intersect. Okay, I've got my point there, and I need an answer. So I'm going to go over 1, 2, 3, 4, down 1, 2, 3. So 4, comma, negative 3. Okay, doing great. Just a couple more here. So I've got negative 4x minus 2y equals negative 12. So let's remember our steps. Move x to the right, divide the y value. So I'm going to rewrite this. Negative 4x minus 2y equals negative 12. I've got to move the x. So I'm going to add it because it's negative. These are gone. Negative 2y drops. X comes first, so 4x, then minus 12. Step 2, divide by the y value. So divided by negative 2, these are gone. Y equals negative 2x plus 6 because it's a negative divided by a negative. So let's graph this one. I'm going to go up 6. My slope is negative 2 over 1. So down 2, right 1. Down 2, right 1. Down 2, right 1. I'm just going to get a few on there. Then I'm going to graph that line. Okay. Now let's do the other one. We've got 4x plus 8y equals 24. I've got to move my x by subtracting it because it's a positive. Now I have 8y equals negative 4x plus 24. Second step, divide by the y. So I'm left with y equals 4 over 8 is 1/2, and it's negative, and then plus 3. So let's graph it. Here's 3. Negative 1/2 is down 1, right 2. Down 1, right 2. And they already intersected. Okay, so here's my point. To get my ordered pair, it's over 2, up 2. So 2, 2. Okay, excellent job. Hopefully you're catching on a little bit to how to rewrite. And we just have a few more. So take a minute and see if you can do this top one here by yourself. Pause it and come back and see if you did it right. Okay, so they're both ready to graph. Top one, I'm going to start at positive 3. slope is 4 over 1, so up 1, 2, 3, 4 over 1. Other direction, 1, 2, 3, 4, left 1, 1, 2, 3, 4, left 1. There's that one. The other one, I'm going to start at -2. And then my slope is -1 over 1. So down 1, right 1 goes this way, but I need it to go the other way. So I'm going to go up 1, left 1, and they just intersected. So here's my point. To get there, I have to go left 1, down 1. So -1, -1. Okay? Last two. Doing great. Here we go. Y equals -2x plus 2. So +2, down 2, right 1, over and over. Here's my line. Okay? And then -2, and I've got to go down 2 over 1. And here's my second line. Now, if you notice, they don't cross. So again, if they don't cross, they're parallel, and we don't have an answer. So that means this would be no solution, like we talked about on the front. Okay. Last one. -4x minus 5 means I start down here at -5. Come on, there we go. Down 4, 1, 2, 3, 4 over 1. So I'm going to go the other way. 1, 2, 3, 4 left 1. Okay, here's my line. And then my second one needs to be moved. So I have +4x going over here. Gives me -y equals 4x plus 5. Then I've got to divide by -1, which makes everything its opposite. So 4 becomes -4, and 5 becomes -5. And look what happens. They become the same line. So if I try to graph the exact same line over top of this one, they're going to match up at every point. So we have infinite solutions.